Hey guys, let's look at the problem finding the equation of the secant line through the points where x has the given values. F of x is equal to 3 times the square root of x is equal to 9, and x is equal to 25. So for this problem, let's first look at what we're talking about when we're looking at finding the secant line. So when we're looking at a secant line, we are looking at a point on the graph where we would have 2 points touching. So we're touching our line at 2 points. And the difference between this and a tangent line is a line that would only touch our graph once. So this would only have 1 point on our graph. So let's draw an imaginary graph and say that we have, I'm just going to do kind of a random example, a graph that looks something like that. So if this is the graph that we're looking at, and we're looking at what a tangent line is, what we're looking at when we're looking at a tangent line is we are looking at a rate of change for a line that would only have 1 point on our original line. And so because it only has 1 point on our original line, we're going to take a point called f of x, and then we're going to take an imaginary point that is very, very, very close to our x value. That is basically the same exact thing as our x value, but we're going to say that it is h distance away from x. So we're going to say this is f of x plus h. So it is only it's x plus whatever the value of h is. But when we're taking this tangent line, the equation would be the limit as h is approaching 0, because basically what we're saying is that h is approaching 0, that h is almost nothing, but it's a little bit bigger than 0. It's getting closer and closer and closer to 0, but it never is becoming 0, so it's never exactly f of x, but it's almost f of x. So instead of it being f of x, we have f of x plus h. So that's why the equation of our tangent line is a limit as h is approaching 0 of f of x plus h minus f of x, all divided by h, where that h is very, 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 very close to 0, but it never actually reaches 0. And so, we would have a point, let's say f of x, you have 2 as your x value, and then whatever that h would be, whatever the outcome of that h value would be, and then your f of x, your y value, we could say that is equal to 6. And so whatever that difference there is a very minuscule difference, because if you're taking a rate of change, you do need 2 points for a rate of change. And when we're talking about a tangent line, we are talking about a rate of change. But since the tangent line is representing an immediate rate of change at this point, it's not talking about a rate of change here, it's not talking about a rate of change here, it is only talking about a rate of change for this value here. We have this line that is representing whatever that slope is of that line at that specific point. So it's talking about basically an instantaneous or an immediate rate of change. But when we're looking at a secant line, we would be looking at a line that is something a little bit more like, we could say it goes from 1 point, and then, so this only touches at 2 points on your graph, but we don't need to use this equation here because we have 2 points that we're able to work with. So when we're working with a secant line, we're going to use a more normalized slope equation, meaning that we can just take a y2 minus a y1 over x2 minus x1, because we aren't working with this kind of abstract idea of h approaching 0, working with a limit as h is approaching 0, a value that is basically the same thing as your f of x, just slightly different, because you can't take a rate of change with only 1 point technically. But when we're looking at a secant line, we are looking at 2 points on our graph. So we're looking at a rate of change between 2 points on our graph. We look at a change between here and here, and what that slope would look like, what that rate of change would look like, kind of between this little area here. So when we're looking at a secant line, just remember that you don't need to use this limit definition here. You could either use the limit as x is approaching a when we're talking about a secant line, or the other normal equation for or I wouldn't say normal equation, just the other equation for working with a secant line. When we're trying to find the slope, we would have the slope is equal to y2 minus y1 over x2 minus x1. And in general, if you're working with a slope of a line, you are using the same exact equation of y2 minus y1 over x2 minus x1. We're just not talking about the slope of the entire line when we're talking about a secant line. We're just talking about the slope between these two specific points on the graph. So when we're looking at our secant line, we're going to use this equation. M is equal to y2 minus y1 over x2 minus x1. And then we're going to plug that into your point slope formula, where you have y minus y1 is equal to m times x minus x1. And so we're going to use this equation to get these points. And then once we get these, we're going to use this equation to get this m. And then once we get this m value, then we're going to be able to plug everything in and get an equation of the line. So I'm going to take what I have over here. And the other kind of tip that you can see for this is you are given two x values. And so having these two x values, if you were only given an x and a y, that's going to probably tell you that you're actually working with a tangent line equation. But since we're given two x values, that's going to kind of tell us that we're working with a secant line, because if you only have one x value, you're going to have the tangent line because you only have 1 point on your graph. But when you're given two x values, that means that you're working with 2 points on your graph, so you can use a pretty normal slope equation in order to find what your secant line is. So our x1, we're going to say is equal to 9. Our x2, we're going to say is equal to 25. Our y1, so how are we going to find our y1? Well, if f of x is equal to 3 times the square root of x, and so we're going to plug in x, our x here is 9, so we're going to take 3 times the square root of 9. So the square root of 9 is 3, so this is going to be equal to 3 times 3, which is equal to 9. So our y2 is going to be equal to 9 as well. And now, our y1 is going to be equal to 9 as well. And now let's find our y2. So we have f of 25, because that's our x value. So we're going to take 3 times the square root of 25. The square root of 25 is equal to 5. So we're going to have 3 times 5, which is equal to 15. So our y2 is 15. So now we're going to plug this all in. So that's the first step that you want to do for the secant line equations. Once you establish what the equation of your slope is, that y2 minus y1 over x2 minus x1, then you're going to take both of your x values, plug into f of x. So take values and plug into f of x. And then once you take both those values, plug into f of x, it's going to give you two y values. And so now we're going to plug everything into our slope equation. All right, so now our m is equal to, so our y2 is 15 minus our y1, which is 9, divided by our x2, which is 25, minus our x1, which is 9. So 15 minus 9 is 6, and then 25 minus 9 is 16. So now if you take 6 divided by 16, we're going to get 3/8. So for this, your m is going to be equal to 3/8. And so now let's plug this into our point slope formula. So m is equal to 3/8, and then our point slope formula is y minus y1 is equal to m times x minus x1. So you can say that y is equal to m times x minus x1 plus y1. So our m is equal to 3/8. We already have that up here. Our x1 is equal to 9, and our y1 is also equal to 9. So we're going to have y is equal to 3/8 times x minus 9 plus 9. So y is equal to 3/8 x minus 3 times 9, which is 27 over 8. 27/8 plus 9. And so now we can take a common denominator and make a common denominator between 9 and 27 over 8. So let's multiply the top and the bottom by 8. 9 times 8 is 72. So this is going to become y is equal to 3/8 x minus 27/8 plus 72 over 8. 72 minus 27 is 45. So your equation should be y is equal to 3/8 x minus 45, plus 45 over 8.